Okay, so for this question, they say the diagram show a swimming pool measures 20 meter wide. So this one 20 meter wide. This shape a bit lari tau. It's like trapezium tapi dia lukisan dia lari. Lukisan dia lari sikit. Lukisan dia lari sikit. Swimming pool, you just imagine swimming pool. Swimming pool, they got shallow part and then go deeper, right? But without diagram, nanti you tak faham pula. So this diagram is for you to understand only. Like that. This is the swimming pool. Okay, with the wide 20, and then the long here 40, then 3 meter at the shallow part and 4 meter at the deep end. Alright, so if the pool is being filled at the rate of 0.8 meter cube per minute, so you are filled up water. So this is meter cube per minute. It means that will be your dV dt. So V is what? Volume about the water. So V here is the volume of the water. It's not the swimming pool. The swimming pool not change. The swimming pool is constant. The shape is constant. Only we fill out the water follow the container shape. So if your swimming pool is trapezium like this, and then your water will be in that shape. So volume of the water, when you fill up, means the volume is increasing or decreasing. The volume inside here will be increasing. So this rate of change will be defined as 0.8 positive. So our first step is identify our shape, identify our changing variable, then what is constant? Obviously, the constant here will be your swimming pool dimension. So what is changing when we fill out the water? The water height here, right? Let's say this one, y. And the water surface. Because you've got shallow part, so you keep on increasing, right? So when you fill out the water, your water is level is increasing, your length of the surface also increasing. And then, okay, what is the rising rate of the water level when the water level at the deepest end is 0.5, means our y here is 0.5. So what is the rate of the water level? Means what's your dy dt? So that will be our first question. After that only we answer this. How long does it take for the water level to start rise at constant rate? Okay, so get dy dt. How to get dy dt? Our second step here, you identify the chain rule that we need. Dy dt, it might be dy, dv, dv, dt. So what we need here is your volume in terms of y. So look at the water here. When you fill in your water, what's the shape of this water? Triangle. So what's the volume of it? So actually it's a triangle, right? Right? So this 20 is constant. The y is constant. Just the x and y is changing. Okay? What is this? This is what? Lebar swimming pool tu bila you isi dia tetap 20, dia tak berubah. Cuma bila I increase, dia akan perasan dekat dasar tu dia punya I ketinggian akan semakin tinggi dan dia boleh nampak I punya X tu semakin, kalau semakin tinggi dia akan semakin panjang lah, betul tak? Until this part. Until this part, the X will be constant, not changing already. But the Y still changing, going up. Okay? So volume. What's the volume of this water? Y, X, this is 20. This is your Y, this is your X. So your volume of the water will be 1 over 2 Y times X times 20. So your V here will be 10xy. Alright, but you can see your equation y in terms of xy. Can we have two variables inside one equation? No, we want to differentiate respect to y. So means here we still have one things to do is relate your x and y. Relate your x and y. How to relate your x and y? How to relate your x and y? Look at your diagram. Okay, we just look at the cross-sectional area here. You look at the cross-sectional area here. Alright. So when you look at the cross-sectional area here, actually in full diagram it will be a trapezium. So here will be constant as 40, but your water just here is just y, right? And then your water here is just x. So what is here? The shadow dip is 3, the dip area is 4. So here is 3, the hole is 4. So this is 1 and this is 1 and 3. So from here you can see a similar triangle. Why similar triangle? Angle is same. But you have two triangles here. One based on 4, 40 and 4. Another one based on x and y. So from similar triangle, we can do our ratio where x ratio, or we start with y because okay, x ratio to y equals to 40 ratio to 4. So what's your x here? X equals to 10y. Is it? 40. No. This one just one only. This one only. Dip here just one only. Okay, so again, the ratio, x ratio to y, another triangle, 40 ratio to 1. So finally, volume 10 times 40 watt times y. Volume equals to 400 y squared. Okay, so then you can start differentiate. Differentiate v respect to y, 800y. Then finally we substitute to our chain rule. You need dy dv. So dy dv inverse 1 over 800y. Lastly, we do our chain rule. Dy dt equals to dy dv times dv dt, which is 0.8. And what's your variable y given at the changes y equals to 0.5. Substitute and figure out. for the other part of the questions, they say, how long does it take before the water level start to rise at constant rate? So when your water rising, so you just imagine when your water rising, so here still changing, but until this part, your x will be constant already. When your water y, your variable y still changing, but your x is constant. Your x won't change because the shape is fixed already, just square. So when you're rising and constant rate means when you reach this cuboid shape, means you already fulfill all the trapezium shape at the bottom here. Okay. So when is it? Okay, so find out when is it. When is it it will be reached until here. How much the volume here? How much the volume when it constant? When your x equals to 1, and then volume is equals to your y is equals to 40. So what's your volume? And then find out what's your time. Okay, so volume or I can take this also can. Volume equals to 400. When it constant means it will be up to 1. Means it will be enough as 400 meter cube. As you can see, dV dt is 0.8 meter cube per minute. From here, what means 1 minute volume will get 0.8. So when your volume is 400, what is your time? So T here will be 400 divided by 0.8 equals to 500 minutes.